Alright, so let's look at some of the software that we can use for interacting with the songline processor. So there's two ways that we can do this presently. We can do it in a pure software setup, or we can do software with some hardware mixed in the loop, a physical box that we can use to set inputs and monitor outputs. This video we're going to talk about the pure software version, and we'll talk about hardware in the loop later on in another video. So to begin with, I'm going to go into my main base directory, which for me is CM3G. This is the directory you can download from the GitLab repo. And there's a bunch of stuff in here, but the main thing we're interested in first is setup-bash. Setup used to work under C shell, may or may not work anymore, so stick with bash. So let me source setup-bash. And it basically just creates a set of symbols for us. So if we look at what that file says, it creates a symbol base, which is this directory that I'm sitting in. So you'll want to change this to whatever your working directory is. And there's three things mainly we need from here. AIO is a symbol for running the synthetic analog I/O interface. Compile is used to compile our code into an executable binary file. And engine is used to actually do the simulation. These other commands are related to doing I/O through a USB port and conditioning the lines and so on, so we don't have to worry about them for now. So first thing we want to do now is run AIO. I'm going to throw that in the background. And this brings up a window of a graphical interface to the songline processor. We have 4 input channels we can choose from, so we can use these sliders to set input values from 0 to 5 volts, and we can monitor up to 4 output channels and see what their value is, and these are our horizontal meters. So we'll come back to this window in a moment. Let's write some code. Let's do a basic hello world. So I'm going to go into a work area, work/old, and I'm going to look at my source file. Now source files for the SLP by default are .txt. So here's my my hello world file. It's got a comment in the first line. The second line is the whole program. It says set TT, set the truth table, and these aren't truth tables, they're functions, but we call them truth tables. So set the truth table. This is row 0, column 0. So the cell in row 0, column 0, we're setting up the behavior of that cell. And we're setting the behavior in particular for the left data output. So L means data left, R means data right, K means data on the third side. CL, CR, CK mean the C outputs on those sides. So we're setting the left data output for cell 0, 0. And this last entry describes how we want that value set. And it's a very simple equation in this case. It's just whatever is coming in from the left side. So LVal means the D input. RVal means the D input on the right side. KVal is on the third side, and so on. And we can do pretty much any C code that we want in here. We can put in if statements and other conditionals, ternary operators. We can do arithmetic expressions. We can combine values from different sides. And do pretty much anything that we want, because this is just a macro. So the whole set of parameters goes inside parentheses. The main call is setTT, has to have a semicolon. We can add comments. That's our hello world. So we'll save that and we'll compile it. So compile and just put in the base name echo, and that should just run and say done. Hopefully it doesn't give you any error messages. And now we've got a new file, echo.bin. As you can see, it's a big file. These things get big really quickly, so be careful how often you create these things under different names. You may need to clean up periodically. Alright, we've got echo.txt. That's behavior of the songline processor. We still need to connect it to this interface, and we do that through a config file. So here's my config file for hello world, and it's got 2 lines. Every line is either a channel number, an arrow, and then a location we want to connect to, or a location in the SLP arrow and a channel number. So this first line is an input statement. We're saying take channel 0 and feed that to cell 00's data left. And take 00's data left and send that to output channel 1. And remember, our program is simply saying take 00's data left and send that to data left. So it's just echoing what comes in from the left back to the left. And so this should basically read channel 0 and send it to channel 1. So we can run this. We say engine, put in a dash to say that it's a simulated interface. If we actually had an interface plugged into a USB port, we'd put /dev/tty USB 0 or whatever the port number is here. So engine dash and then the base name of the file, and it gives you some information. It says, okay, input channel 0 is driving this. We're monitoring this side on channel 1. And now if I slide channel 0, we see channel 1 changes in response to that. So I can put the slider halfway and we get 2.5 volts coming out, and we can drive the input up to 5 volts, down to 0. And that's pretty much all it does. We get these periodic sync messages down here. Don't worry about those. That's just internal communication between the engine and the interface. So when we're done with this and we want to exit, we can hit the attention button and the software will exit. It will say attention signal detected, goodbye. And it'll tell us some information periodically about how many cycles and events have executed. And it'll show us this when we exit also. If you want to exit the analog interface, you can exit out, or you can just hit the exit button. And when you do that, the AIO code terminates. Alright, so that's our first hello world. Next video, we're going to start digging into more interesting programs, and we'll see some options for what we can put inside a cell, and we'll play around with some other circuits. Alright, thanks.